Hello, everyone. So, tonight, as you know, we're going to finish the Dwarf Planets. And this one's going to be a little bit longer because we're going to get into some detail. So, just to remind everyone, the explainer on what makes a brown dwarf is in the What Is playlist. So if you want to go back and watch that quickly before watching this, it's about 14 or 15 minutes long. But here's just a little quote from the IAU from 2006 when they established the what is a planet. So they said, a dwarf planet is an object in orbit around the sun that is large enough to pull itself into a nearly round shape, but has not been able to clear its orbit of debris. So if you want to go back and watch, that's fine. But that's really all you need to know about why these planets are dwarfs instead of full-blown planets. So I'm actually going to start with Ceres, or Ceres. I've heard it different ways. This is probably going to be the shortest one, but so Ceres is, or Ceres, I usually say Ceres, is this small one up here. It is the smallest, I believe, with a diameter of 940 kilometers. So yes, it is small compared to these these other dwarf planets. So as you can see, it's also elliptical, a little bit more so than like Jupiter and Earth. Earth has a nearly perfect orbit, but it resides inside of the asteroid belt, as you can see, between Mars and Jupiter, but it is still only 2.77 AU, and so Earth is 1, and Mars is about 1.5, and then Ceres sits just outside of that. And to compare, Jupiter is on its closest is 4.9, and its farthest is 5.4 AU. And then down here you can see that it is inclined more than. All of the planets reside in the same plane, but as we've seen from asteroids and the other dwarf planets, they have pretty inclined orbits. This is, it's actually, there, let me zoom in a bit. Very fuzzy photo. Ceres is listed as an asteroid with in the NASA database, and it was labeled that for a really long time until 2006 when they established dwarf planets. So technically it's an asteroid, but because it is circular, it is considered a dwarf planet. Because it is circular, it has the mass to be circular. Actually, Ceres has the largest mass of the entire asteroid belt. It actually holds a third of the mass of the entire asteroid belt. Its mass is 10 to the 20th kilograms. So if Ceres were to move outside of the asteroid belt, either further or closer, it would take about 33% of the mass of the whole asteroid belt with it. And, I'm sorry, the mass was actually 9.1 times 10 to the 20th kilograms. I didn't look the line above to finish my sentence. Sorry about that. But I did have a picture on here, but I can't seem to find it. I know you can see in this image that even though it's blurry, you can still see the very bright spots. Let me just try to find that image that I have. Okay, there we go. I found it. So this one you can see the two bright spots. And so these spots are actually, so first let's start with the crater itself is named, I really hope that I am going to say this properly, but Okator Creator. Okator Crater. It's a very rhythmic name. So these two bright spots are this first spot, which is actually the first one that was noticed. I know, let's see, it was, as I said with this one, which I originally thought was the only, that we didn't have a clearer photo, but then I remembered I had the other one. But even in this one, you can tell it's there, but it just looked like one. And so when they got this clearer view, they realized it's not just one, it's two. So this first one right here is called Cerealia facula. Cerealia facula. I really hope I'm saying that right. And the dimmer one right next to it is Vinalia faculae. They are highly reflective salts. So these are compound salts that are that were created due to a push upwards of really salty, briny water. And this was only within the past couple million years. As we know, the Ceres was formed when the asteroid belt was formed, but these didn't happen until just a couple million years ago. And so the salty, briny water pushed through to the surface, and then the water around it evaporated. And it is very cratered heavily, just like our moon, and I mean that's expected because it's within the asteroid belt. But that is what really caused the water to start coming up. I don't actually know if there's still water there. I didn't actually see any writing on that. Okay, let's see. But due to its shape and its density, which is 2.2 grams per cubic centimeter, because of that, that suggests that it's a rocky core surrounded by an icy mantle. So if water did exist here, then it would be in that icy form in the mantle. Probably not liquid anymore, seeing as these salty spots exist, and the water would have evaporated because there's no atmosphere there. A lot like our moon. So I hope that helped you understand Ceres a little bit better. But now we're going to move to the Kuiper Belt, and that's Pluto. So let's get to Pluto. So here's the lovely Pluto. Let me center that. It is like reddish, as you can see. And Pluto is, it was the demoted planet. It was a planet, and now it's a dwarf planet. But let's see. I actually want to start with how Pluto got its name. And that's this young lady right here. So, let me... Oh, I can't back it up. Okay, so this young lady, in this photo, she was only 11 years old. And she was living in England, Oxford, I believe, with her family. And she was at the dinner or breakfast table with her grandfather when he told her about them funding the 9th planet. So, in 2006, before the actual demotion of Pluto, NASA interviewed her, and she was in her 80s, but she recalled clearly that it was March 14th, 1930, when she was sitting with her grandfather, and he told her, and she just became fascinated with this planet and suggested to her grandfather that they name it Pluto. And so he wrote in for her. He wrote to them and told them that his granddaughter and I would assume gave them probably this photo, and that she wanted to name the planet, and gave them the suggestion of Pluto. And I'm assuming because she was so young that they really took a liking to how fascinated she was at such a young age, and they took the name. They used it, and obviously they gave her credit for it. This picture was actually donated by her herself. She gave this photo to them. Oops. Okay, I went too far. There we go. Zoom in again. So, Pluto, named by this young lady, is the largest object in the Kuiper Belt. Although it is still quite small, it has an equatorial diameter. So, around the equator, the diameter is 2,377 kilometers. That's about 2/3 the size of the moon. So if you were to take the moon, cut it into thirds, it would be 2 of those thirds. And it's an elliptical orbit, as I had mentioned in when I was just talking about Ceres, and in my previous Orbits Live, Kepler predicted that one of his laws is that all orbits are elliptical in some way. And the Pluto orbit is, I'd say, quite drastic. So at its closest, it's actually 30 AU. And at its farthest, it's 49. And I see in a lot of the work I have to do, especially in labs, that we tend to round to 40. But it's actually 30 to 49. So long orbital periods because of the distance. So the further away something gets from the sun, which is the largest mass in our solar system, then the longer it's going to take to go around that object, making Pluto's orbit 248 Earth years. So, because it was found in or discovered in 1930, it actually will take a couple generations to actually fill one or fulfill one orbital period since its discovery. You know, an observed orbital period. Obviously, it's fulfilled quite a bit since the beginning of the solar system. Since it was 1930, it's only been 95 years since its discovery. So it's only fulfilled 95 of the 248 since we've observed it. But its day is also very long at 153 hours on Earth. So it has a long orbital period and it has a very long day. But because it is actually so far, it's icy. Unlike Venus, where its orbital period is very shorter than ours, because it's closer to the sun, but its days are longer than our year. And it's very hot. This has a long day and a long year, and it's very cold. Pluto was observed close up in 2015 when NASA's New Horizons telescope passed by. I believe that is actually where this image came from. Going the wrong way again. Yes. So this image actually is from the New Horizons pass by. So Pluto has moons. For a really long time. See, look, this is the New Horizons telescope. And this was actually taken from an interactive that is on the NASA website. I believe it's science.nasa.org. For anybody who wants to go check it out. It's really cool. You can use the time controls here to make it either live or you can make it go faster or slower or whatever. But this shows Pluto, the 5 moons, but I realized that time controls got in the way. And it also, I wanted to get these in there too. So New Horizons is right about here compared to Pluto. So it's past Pluto. And you can see its trail coming from this way. So that's where it's gotten in the past 10 years from when it took the photo in 2015. But here you can see Pluto. And Charon is the first moon. And Charon is actually the only spherical moon that Pluto has. Then there's Styx. Styx is actually my favorite name of all the moons. Nix. This one right here would be Kerberos, and this outer one is Hydra. So these 5 moons orbit Pluto. Charon is spherical, but Styx, Nix, Kerberos, and Hydra are lumpy and they look more like asteroids than spherical moons. But another thing is that Charon is actually quite large compared to its parent planet. If you look at the moons of Jupiter, they're all pretty large, but Jupiter's massive, so it doesn't actually make them look that large. Our moon is actually kind of large compared to us. When we compare them, when we compare the other, like Mars's two little asteroid type moons as well. But Charon, when you compare it to Pluto, is actually quite large. This is the Hubble image of Pluto shines in the center. Charon, as you can see, it's meeting it more than halfway in size. And then you can see the little glows of Nix and Hydra. And so in between Nix and Hydra would be Kerberos, and then Styx was in between Charon and Nix. And yet another one. So this one has distance measurements in them, actually. And you can see where they have... So I don't know why they have Nix listed all the way out here when it's actually supposed to be... they should have put the name down here. But there you can see Hydra, you can see Nix, you can see the little dot of Kerberos there. It is very small. And again, it's more asteroid-like. And then you have Charon. And it says Styx, but I can't... Styx is, again, a very small, like, asteroid-looking one. So I think it might be this little brightish spot right there. But this black strip is here because they had to block out the light from this one. So the image would have looked like this, just zoomed in a bit. They superimposed the orbits, obviously, but they had to block out all of this excess light around here so that they could actually see the rest of the moons, and that's how you can actually get this little glow over here from Kerberos, which is small, and then again this possible one from Styx. So this one actually shows how they're orbiting. So this is Neptune's orbit right here, and then you can see Uranus there. And then you can see the little corner of Saturn's name here. But you see, this is the plane up here. This matches and this matches. They're on the plane. But then Pluto, not only is its orbit strange, it goes up above the galactic plane. Or it goes up above the plane of the solar system. And it goes back down. It has, one of those orbits. But the moons are actually orbiting... more like up and down compared to the plane of the solar system. So if you were to angle it to be more flat, like the rest of the solar system, they're all orbiting in the same way. So they're all going the same way around Pluto as the planets are going around the sun. And, the moons are going around the planets. But as you can see, instead of it being on the plane, it's almost 90 degrees. Because Pluto is so far from, between 30 and 49 AU, the temperature is very, very cold. So Pluto's surface temperature is between negative 226 degrees and negative 240 degrees Celsius. This makes the body, this makes the surface very cold. But there's also a lot more to Pluto. If I can find that close up, oh, here it is. So there's actually a lot more to Pluto. Let me get this part over here. Pluto has mountains and valleys and plains. It has a lot of features that um, uh, all of our other rocky, us, Mars, Venus, all of the other rocky planets. And these aren't just things that came about because of like a bombardment, like Ceres has just littered with asteroid or meteorite hits. But these are formations as any other rocky planet. Pluto's tallest mountain peaks are between 2 and 3 kilometers high, and the largest craters are around 260 kilometers in diameter. And these all are pointing towards tectonic shifting, meaning that it developed a lot like Earth, where it has tectonic plates and they shift, especially when it goes from far away to closer. That 19 AU distance creates its own temperature shift for the planet itself. But this is actually, I tried to get a little close up of an example of the plains. And these plains actually have evidence of salts and minerals. And that's one reason why they are different colors, or why they tend to be lighter than the reddishness of the surrounding areas. So before we move on past Pluto, this last image that I'm gonna show you, again, it's not an actual like image, but this is that interactive. This is Pluto right here, and this is the view from Charon. Pluto and Charon are this close. They are very close together. If you were to compare, if you were to have somebody standing over here on Pluto and looking at Charon, if you were to compare it to Earth, it wouldn't look like when you look up and see the moon, because the moon is slightly larger than, a third larger than Pluto is, but it's also quite far away. It's over 300,000 kilometers away. So the angular size is actually quite small. But if you were to be standing here on Pluto and looking at Charon, it would look a lot larger. It's closer than the moon and Earth are. But again, the size comparison is almost the same. And so now after Pluto, we are going to get into Eris. And first, I'm going to tell you a little story about Eris and how it started the debate. Okay, so Eris, this lovely little dwarf planet, began the debate because when it was discovered in January of 2005, the data that led to this 2005 observation came actually in 2003. And so after 2 years, they did find Eris. It was during a survey of the outer solar system. So in January 5th, to be precise, of 2005, they found this planet, or this object, in the Kuiper Belt. They named it, the people who found it actually named it Xena. And if the first thing that popped into your head was a person, then you are correct. Xena was named after the character Xena, warrior princess. And Xena was portrayed by Lucy Lawless, which is actually one of my favorite actors. She's in one of my favorite shows, which is Battlestar Galactica. That's what this is from. But yes, they named it Xena. That was its provisional name based off of the TV show. And so, yes, they named the provisional name was Xena. I think I might have actually liked that one more. I know that they renamed them, after trying to keep in line with the names of all the planets, really, but I still think Xena is an awesome name. So on January 5th, they discovered Xena. Then 3 days later, on the 8th, that's when they announced to the world that they found a Pluto-sized object beyond the orbit of Neptune. That would mean in the Kuiper Belt. Then in September of that year, so September of 2005, they announced that they found a small moon orbiting Xena. And as you could probably already guess, if they had Xena, then they needed Gabriella. So they named the moon Gabriella, and her character was portrayed by Renee O'Connor, if anybody remembers that. And so then, almost a year after they found the moon, in August of 2006, that is when the debates came to an end at the IAU, and that is when they established those parameters that I listed before. And just about a month later, that was when they renamed Eris and Dysnomia. So, as some of you probably already know, Eris is named after the Greek goddess of discord, and Dysnomia is the demon goddess of lawlessness, and also the daughter of Eris. As you probably would recognize, most of the names of the moons are children of whoever the planet was named after, or in this case, dwarf planets. So yes, in August of 2006, that was when they established the parameters, and Pluto became a dwarf planet, and Eris was also labeled a dwarf planet. So this is the same interactive as the other ones, but this is the dark side, because I wanted to turn it around and look at the plane of the solar system, and I just wanted to show like the distance comparison. So as you can see, the Neptune's orbit, which is already very far away, it's farther than Pluto at 68 AU. And actually, of the four major dwarf planets that are in the Kuiper Belt, it is the farthest of all of these. So you have Pluto, which is the closest of all of them at 30 to 49. And then you have as great a distance as Eris here, which is 68. And again, that's 68 times the distance from Earth that Earth is to the sun. And we're already, 93 million miles or 150 million kilometers away. So Eris here is uh, 2,400 kilometers in diameter. That makes it a fifth the size of Earth. And its distance at, as I said, 68 AU, that makes the year 557 Earth years. So if you just do the math on that, since it was found, if you take the time at 557 Earth years, and then it's discovered in 2005, it will take about 6.5 generations from its discovery in 2005 for it to complete 1 year. And that's giving an average lifespan of 85 years for humans, which I think is pretty generous. I mean, I know people live longer, people live shorter in some areas, but we'll just say the global average of 85. But if you want to just do that on your own, you can actually look up what the actual average of human life is and see how many generations it would take for Eris to complete one orbital period. And so even though its year is very long, its days are actually not that long. So an Earth day is 24 hours. But Eris's day is 25.9 Earth hours. So again, if you do a little bit of math, with a year being 557 Earth years, and a day being 25.9 Earth days or Earth hours, that would be about 189,000 days of Eris days for a year. So our year at 25 or 24 hours in a day, we have 365 days a year, approximately. Every 4 years, we get that extra day, but it's 365. 1 year to Eris is 189,000 days. That is really a long time. Obviously, in order to turn one on that planet, you'd have to go through generations. It is very far, so again, the surface temperatures are quite cold, and they're always negative, and for Eris, that would be negative 217 to negative 243 Celsius. That is actually a pretty big swing in temperature. That's actually a bigger swing in temperature than Pluto. And this temperature shift makes the atmosphere that it does have collapse, freeze, and then fall back down as snow. And that is all quite interesting, I'd say. A planet like this wouldn't ever be able to support life. And now we are going to move on to Haumea. So this, I call it the quirky little oddball because it is quirky. and it is oval. It is an oval. This this dwarf planet was actually discovered in 2003. So there's actually two claims to it, one in 2003 and one in 2004. But the official claim, or the official documentation of it, says 2003. And it was discovered at the Sierra Nevada Observatory. Not in Sierra Nevada, though, in Spain. I had to read that a few times when I first saw it. I was like, is this correct? I actually didn't know we had a Sierra Nevada Observatory in not Sierra Nevada. And I know people from there are going to say it's Nevada, but no, it's Nevada. This oblong shape of Haumea comes from its rapid rotation. It formed at the beginning of the solar system, just as everyone else, but its rotation is so fast at only 4 Earth hours that it has, when it was forming and when it cooled, it settled into this oblong oval shape. And its equator is actually the longer part. Its equatorial diameter, so right around this right here, is 1,740 kilometers. It sits a little bit farther than Pluto, just past it at 43 AU. So that means that actually Pluto goes in front of it at its closest, and then actually farther away at its farthest. And Haumea was actually the first known Kuiper Belt object to have rings. The other ones that I've mentioned, so Eris, Pluto, and then after Haumea, I'll talk about Makemake. They don't have rings. None of them do. But Haumea does. The rings were discovered in 2017 when we observed it passing in front of a star. And they noticed the glow of the rings around it. And this is a view from, again, the dark side of Haumea at the solar system. As you can see, it's also above the plane, so just as Pluto and all of the other dwarf planets, it has a very inclined orbit around the sun. And so this is the dwarf planet and its 2 moons. Haumea gets its name from the goddess of fertility. And the 2 moons, which this closer one is Namaka, and the second one is Hi'iaka. So Namaka is actually named after the daughter of Haumea, one of. Hi'iaka is the other daughter of Haumea, and is the water spirit. And then Hi'iaka is the patron goddess of the island of Hawaii and of hula dancers. So I actually lived in Hawaii for 4 or 5 years, and I can say I never saw hula. So a lot of the time, my husband was actually gone because he was in the military. So part of his deployment, his full deployment, the whole time, I didn't even have a car. So the only things I did were things with friends and my friends who also had kids. And we would just mostly go on hikes and stuff like that. But I never actually went to a hula show. And both of these moons were discovered in 2005. But unfortunately, we know very little about the atmosphere, and we don't really know about the structure of it besides that it's rocky and icy, just like the other Plutoids. And after, let me just make sure that I have these listed properly. Here we go. So this is that same interactive. I zoomed out and I had I had it list dwarf planets as well as planets, and I took away all of the, like all the satellites and stuff that would show up if I had kept them on. And you actually get this little Sedna over here. But you have Eris here, and you can see its orbits going like this. You have Makemake coming this way, Haumea going this way, and then Pluto, being the closest of all of them, going around this way. Okay, so this is actually Makemake. Just like the other from Eris and from Pluto, this shows a tiny little moon here. They were not discovered together, though, like Haumea was in 2003, and the moons were 2005. There was only a 2-year gap there. Makemake, which is a little bit smaller than Pluto by about 800 kilometers in its diameter, at 1,430 kilometers. But Makemake is also important to the history of the solar system, solar system studies, because it was right there. It was discovered just 2 months after Eris. And both Eris and Makemake, being both similar sizes to Pluto, both of them are what led to that discussion and the debate about what is a planet and what is not a planet. So thanks to Eris and Makemake, this planet right here, that's what we have the definitions. So, helped us define our neighbors just a little bit better. So credit for Eris, Eris, but credit for Makemake, just like Eris, was through the Palomar Observatory. And it took until 2016 to discover the moon. And just to put this into perspective a little bit, that means that it has been 20 years since Makemake and Eris were discovered, and 22 years since Haumea was discovered. But this moon of Makemake wasn't discovered until 2016. That was 9 years ago. There's actually not that much about Haumea, so they believe they don't have actually that much data on the surface or the atmosphere or any of that. But because of some of the observations, better than the previous one that I showed, this is what they believe it should look like. It should be reddish brownish, like Pluto is. It is as I said, it's just a little bit smaller than Pluto, and it's only a little bit farther at 45.8 AU. So again, with Pluto's very eccentric orbit, that actually puts Pluto beyond Makemake at some points. But this distance makes the orbital period 305 Earth years. As we saw with Pluto, that's just a little bit farther, or a little bit longer than Pluto. Of course, this is measured in years, so from 248 to 305 is actually quite a long time for humans, but comparatively, it's not that long for the solar system anyway. That moon, it still only has a provisional name, and they call it MK2. It is as close as 13,000 miles away from Makemake, and its radius is only about 80 kilometers. So it is quite small, which you can actually see in here. Unlike with Pluto and Charon, where you could clearly see that Charon was quite close in size compared to the glow of Pluto, you can see that this one's quite small. And it does share some similarity. It does share one similarity with Haumea, which is that Makemake is the name of the Rapa Nui god of fertility. So they're both named after god or goddess of fertility. So that is actually all I have on the planets. I really hope it was detailed enough for all of you guys. But before I actually go, I am going to just go through some of these other ones that I have. So this is from the view of Eris, I believe. Yes, because you have Pluto over here, you have Haumea and Makemake, so then this one would be Eris. And if you rewind and go back to the other image that I had of looking back at all of them, then you would see this lines up. This would be Eris, and then you have the other three over here. This is the New Horizons, I believe. I wanted to get I clicked on it because I wanted to get just the view of it. Like this is what it looks like, and this was the one that passed by Pluto and got that close-up image, the first one that we ever got. And here's just another image of, you have Pluto and its 5 moons, and then you can see Voyager here in the distance. And then this one is also Pluto, and you have all 3. So you have Voyager 1 over here, you have New Horizons, and Pioneer 11. And as everybody should already know, Voyager 1 is actually very, very far away from where Pluto is right there. It's well beyond Pluto, but it went that way. So that's why that trail is there. So here's the last look at them. We have the largest being Pluto, the smallest being Ceres, And then we have Eris, Haumea, and Makemake. And in order, that would have been Ceres, Pluto, Haumea, Makemake, and then Eris, the furthest away. So I have really enjoyed this one. I took a lot of detailed notes. So I'm thinking of a way that I could start sharing my notes with everybody. And if you didn't see in my last video, you can go back and watch again. But this weekend, I looked it up. I looked at my forecast, and it should be clear enough for me to be able to take my telescope out, put this little eyepiece on it, and get some good, useful images and some shorts to put on the channel. I also hope that my little hint for the code right down there, I hope that it worked and that some of you are starting to figure out what it means. I said the first one is a J. So now you gotta plug in a J there and then look to see, what other letters could be there. And you really have to think about placement. Which letters of the alphabet are more likely to be in the places that they are, especially the repetitive ones? So if you can figure out at least one of the repetitive ones and figure out which letter that is, and just to understand codes like that, you have to realize something about the alphabet. The most common repetitive letters are going to be vowels. So it's another little hint. Now you have 2 hints. I really hope to start seeing some comments of what it could possibly be. And if you're in my Discord, which again is linked everywhere, but if you're in my Discord, you can always try to tell me on there too. But for tonight, we can just ponder all of the new information we have on Dwarf Planets. Maybe it will help some people not be so upset about Pluto anymore. I know I was definitely one of those people who held on for so long that Pluto was a planet. Because, well, I mean, I'm not going to lie, in my heart, it probably still is a planet. But accepting the fact that it is a dwarf planet, understanding that, then you can start to really take in all the information and accept Pluto for what it is and still love it anyway. So that's it for tonight. Have fun, have a good weekend, and hope to see you back for the next video. Who knows what it'll be. Keep looking up.